Welcome to another episode of Breakout Boards for PCB Development. And today's subject is, well, really not a breakout board at all, but I just couldn't be bothered to change the title. So today I'm going to talk about the LED tester and why I think that everybody should need one.
Like and subscribe.
Today I want to talk about my take of the LED tester, why I built it, why it's so overly complicated, but more importantly, why I needed it. Now, obviously, I don't need to explain the function of an LED tester, and most people will be like, well, why test it? I mean, all the modern LEDs are just fine. Unfortunately, that is not always the case. If, for instance, you got a project like this that has over 200 LEDs, special LEDs in this case, and you order them, and you solder them in, and you find out that half of them don't work, now, I can tell you that's a very expensive mistake to correct. And that's just for the normal LEDs. You could have a project with smart pixels like this NeoPixel, which you kind of do want to test. Or even normal LEDs, but on a very, very small scale, like these SMD LEDs, you definitely want to test them. And not just to make sure they work, but most often I test them to find out the orientation. Because at the 0201 level, or smaller, the 01, 005 level, there are really no markings anymore. So you have to test them before you pick and place them. That's just a given, you have to. And I always ran to my nearest breadboard, and I found one that was actually empty, and you put on a resistor and some LEDs and all that jazz. And you try to test your LED. So let's just do that. Let's give you a practical example. If I can get this USB-C in, which would be nice if it's actually USB-C cable. Excuse me, that's what happens with live demos, unfortunately. They never work. All right, USB-C. There you go. Love it. Now, to test an LED, obviously, that's not hard. You just pick the lead that's the longest, and that will be your anode, which in this case is totally useless. That's why I don't teach people that. And you put it in and nope, doesn't work. Turn it around and there you go, Bob's your uncle. Now that works fine for single LEDs. And I always advise you to test it even if you have small projects like this. This is an early design of the internet, and IT people will know what I'm talking about. Even for single LEDs, always test them. But sometimes you come across specialized LEDs like these. These are blinky LEDs. And they have a chip in them, and you definitely want to test them. And that's all good and well, but what about smaller LEDs? What about these ones? How do you test these? Well, again, you don't need electronics. What I usually did is, again, grab my breadboard, put in 2 leads, try not to short circuit it, and then try to connect them to the leads of the LEDs. And the reason why, like I said, it's not just to figure out if they work, but more importantly, to find out the orientation. Only to find out that if you put too much pressure, they jump away, never to be found again. So it's just a nightmare. And that's just regular LEDs. I mean, what about NeoPixels? How do you test those? Well, I needed to find a way to do it. So I came up with my test jig. And this consists of 2 PCBs. So you got a bottom PCB and a top plate. Now, obviously, to test normal LEDs, you don't need a microcontroller. You just need power. And I didn't need a microcontroller, but I did want to test a few LEDs I use a lot. The first 3 are WS1228B or clones, the 5050 variety, the 3535, the side emitting ones. And the 4th position are for APA 102s. Those are different type of LEDs. And in this case, it's a 2020. So that's very, very small. You can see the pin pitch is very, very tiny. So obviously I needed a microcontroller. And since I had an abundance of ATmega 328Ps, I chose that chip. But you can choose any chip. Doesn't really matter. Now the first problem I came across is what surface finish am I going to use? And my initial board, let me just get that for you, had a hassle finish. And the advantage is that it gives you an incredibly strong bonding because it's similar to the solder material, but the downside is it's not level at all, like it's terrible. So this didn't work out. So my next option was, let me get this board, Anik finish. The advantage of this is that it's incredibly level, and as an extra bonus you get a gold layer which protects the contacts for erosion and stuff. But even this didn't work because while the board was perfectly level, most component legs aren't. So I needed a combination of two, and I found out that if I put solder paste on it, and it had a flat surface to begin with and it spread out, and I flattened the solder paste with a, in my case I used a block of metal which was perfectly flat, I got the desired result. So without further ado, let's demo it. And now I need my my micro USB cable back. Now I didn't use a USB-C cable on purpose because costs. I mean, this thing only needs to provide power, so it's a bit silly to use an expensive USB-C cable. Now the first 4 or 3 rows are for your garden variety LEDs. So we've got the normal ones. We can test them here. Put the cathode to the right. All the cathodes are to the right, so obviously it's working. And you can use your special LEDs as well, the blinky ones. Next position, SMD. Now let me just see if I can do this while looking through the camera. But you should be able, if I get it just right, you can see it flash, so that will work. And obviously I got the 06, 03 size as well. And last but not least, even though it's not part of a normal LED tester, I wanted to find the orientation of diodes. And as you can see, now I know that the cathode is on the left, so it makes it easier to pick and place. Because it's the same issue, the smaller the components get, the harder it is to find markings. Now the electronic ones, so I basically routed these out, and that was not easy to find the right routing. But you just drop it in, you can see the markings on the bottom, and you just press them and you get red, green and blue. Now the buttons here have 3 modes, slow if you want to test them, but if you have to test a lot you don't want to wait that long, so you just go to the fast mode. And the last demo mode gives you an example of color mixing, so it gives you a rainbow pattern, so that's kind of nice. So let's get this one out and go to the next one, the 3535. Again, slot it in, press, and there you go, red, green, blue. It's a bit harder to get out. Now here we have a side emitting one. These are always a bit challenging. Let's see if we can make it work today. Get in there. Come on, I know you can do it. Now the reason why I am struggling is not, well, that doesn't help. It's not because it's so hard to get in, but I'm trying to look through a camera and that doesn't make it easier. So yeah, there you go. So that one works. Don't need to go through the full cycle. And last but not least, these ones, the APA 102, and they are very hard to test. And you can see red, green, blue, perfect. And trust me, these are tiny. I don't even know if you can see them properly, but they're very small. So that's my take on the LED tester. As you can see, it's got a nice finish. These are M2 screws, 3 millimeters long, so they don't protrude through the bottom. And yeah, it's a very nice small design, something every workbench should have. I put the programmer header on there, and because it is basically just a microcontroller with a lot of free ports, you can actually abuse it for other stuff. You can actually write firmware code that allows you to test these NeoPixels by pushing them into the SPI bus, and you just have to reprogram these pins and you can test these LEDs as well. So if you like it, just leave a comment and you will be able to order these soon. As soon as I've got my website up and running. But yeah, this has been a lifesaver for me. Like I said, not just to test them, but also, and more importantly, to find the orientation of LEDs during big builds like this, for instance, or very small boards like these, just to figure out what the orientation is. So if you like it, leave a comment below and I'll see you next time.